G'day Year 7s. It's just the first video to introduce our maths project that we're doing to finish off what has been a pretty busy term of maths. In this video, we're going to look at just an introduction to the projects and starting to get work on part A of the task. So I've started in sector, and there are 4 resources for you on sector. There's the task sheet that'll take you through the project and the core of the project. There's a photo of the way you can format or lay out your project. There's some more instructions about the task and some more instructions about how you can write the project up. So let's quickly have a look at each of these. Let's start by having a look at the task sheet. And here we're really keen, it's due in on Friday, and teachers will talk to you about when we have to add that in. There'll be time given in class to work on it. Here's the task. We're looking at grids up to 5 by 5. We're trying to work out how many rectangles fit on those grids. We're trying to organize our thoughts in a systematic way, kind of a mathematical way, and communicating to be clear and concise. And I often say once you get to secondary school, the point of communicating your maths is so that other people can follow your process and do the same thing if they need to. So you want to be really clear about what you've done to get to a solution. Let's have a look at the second thing, which is our format, how we're going to set things out. We start with an introduction, the problem in the own terms, where we just looked at what the problem is. So in your own terms, you might say, well, we're going to look at grids of up to 5 by 5, and we're going to try and work out how many rectangles are in each grid. What are some key terms? Well, one of the key terms is probably going to be rectangles. We know we've talked about some of the language of conjecture and counterexample, so we might use some of those words. Maybe there's some other words you come across you need to know. Don't have to do a lot. Try and pick 3, 4, 5 terms that are important. Okay, and what are you trying to achieve? I kind of said we're trying to estimate how many rectangles we can find. So that doesn't look too complex there. Let's have a look at the third one. Actually, let's go to the fourth one. The fourth is just what we can do. How you can write this up in your special project book that you either will have been given or will get given. What's the problem in your own terms? We've already looked at that. We've looked at the key terms, and what are your expectations? What do you think you're going to be able to do? Once you get into it, then we're looking at these other things. What are the strategies? How did we go about doing things in a systematic? I think the word we started with was systematic way. Yes, systematically. So how do we go about what we're doing in a systematic way? Explain your system. Maybe you started with 1 by 1 shapes, and then you went to 2 by 2, and then you went to some 1 by 2, 2 by 1, and so on. And what are the tools you're going to use? A lot of the tools are just going to be things right in front of you. So you can actually start now, if you want to pause here, and do those first 3 things in the introduction. What's the problems in your own words? Find some key terms. And what do you think you're going to achieve? Let's keep going and get on with the first part. We're going to go to that resource that we didn't download, which is the rectangular counting presentation. And we start with the 3 by 3 rectangle. And there's a table. You'll see a table here a little further on, right? It asks us to work at the number of rectangles in a 1 by 1 grid and 2 by 2 and so on. So what I've done, if I just emphasize here, let's have a look. What we're doing is we're laying out a pattern of 3 by 3 dots and then connecting them. We're interested in the shapes that we can make as we connect those dots. And one other important thing is we're not worried about diagonal shapes at this stage. Okay, if you could make a diagonal rectangle, I don't think you can on a 3 by 3, but on bigger grids you can. We're only looking at ones that are kind of have a side that is parallel with the ground, if you like. So let's get stuck into this. Let's go into my notebook. Here we've got some of the different grid sizes. Well, if you start by 1 by 1, right? I apologize, I've done a little practice working out here. I'm not very good at my drawing, so it should be entertaining if nothing else. Let's start with just a 1 by 1 grid. Right? It's effectively just a dot. And there's no way you can draw a line out of the dot. So the number of rectangles in a 1 by 1 grid is going to be 0. Let's take it a little bit further. Let's think about a 2 by 2 grid. Now we're going to come to a special question here. I'm happy to say I had to double check this question. Mr. Greeny, as we started off this assignment, and said, is a square a special sort of rectangle? Remember we talked about those words that you had to define. Well, rectangle looks like a key word to me. Turns out it is, because a rectangle is defined by having the 4 90-degree angles and straight sides. So let's draw, how many shapes can we draw? Rectangles. See, I didn't say I wasn't very good at the drawing. So I can draw a 1 by 1 rectangle. So in a grid that is 2 by 2, so I can get rid of this. In a grid that is 2 by 2, I can only draw that one rectangle there. That's the only way I can draw that. So in a 2 by 2, should have filled this in earlier, 2 by 2, number of rectangles is 1. Okay, so next we're going to go to a 3 by 3. That's what we're asked to look at. Now, I want to be really clear in that somewhere in the task it asks us to do it 2, 3, 3, then I do 3 in the next row. So I'm going to have 3 across, 3 down. Now, as they ask us to do it, they do ask you to do it in a systematic way, and when you get to do it, a different rectangle for each one. So each time, each new rectangle should have a different diagram. Okay, so what that means is, let's say I start here and say, okay, I can do my first rectangle here. 1, 2, 3, 4. So that's a rectangle, a 1 by 1 rectangle. We know it's a square as well. It's also a special sort of rectangle. And then I can draw my next array of dots. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I draw my next rectangle here. Let's say I'm systematically going through. Now, the work was systematically. So I think it'd be a great idea to make a comment saying, okay, I'm going to do all the 1 by 1 shapes I can find, moving around the shape in the one direction. So I can probably see there's going to be 1, 2, 3, 4, 4 1 by 1s. But is that going to be the only thing that we do? The answer is the only shape. No, we're going to be able to find some other shapes. So let's quickly go through and put my array together again, 3 by 3. Another shape that I can find. So I've got 4 1 by 1s. The shape I can find is that there's a 2 by 2. I can go all the way around here. So I can draw that in and put that in. So that's another one. We're going to add all these up. Now I've got ones that can go too long, rectangles can go too long and one up. So there's one there and one there. So there's another 2 rectangles there. I don't think I'm quite finished yet because I can do 2 this way. I can do that 2 high and 1 across. 2 high and 1 across. Remember, you want to be recording that we're doing this in a systematic way. So when I add all those up, 4 plus 1 is 5, plus 2 is 7, plus 2 is 9. When we do the 3 by 3 rectangle, there's going to be 9 different shapes. Okay, so we're starting to see a little bit of a pattern. That's our start of what we're going to do. Right? That's the introduction and part A. Remembering as you do it, when you set out this 3 by 3 grid and draw the rectangles, you're going to have a different 3 by 3 grid for every rectangle. So if you find that there are 9, and I don't know how many you'll find, because I may not have done it correctly, if you find that there's that many, you're going to have that many different arrays with each having one individual rectangle, just like I did to demonstrate the first 2, and try and work out a system to do it.